Thank you. So, hi everyone, and thank you for joining this session. It's hardly a secret that the development of secure software can be a formidable undertaking. Application software can be riddled with many security vulnerabilities, and they can pose a significant and serious risk to organizations and their clients. But vulnerability remediation consequently become a cardinal part of the overall software development workbook, if you will. But that being said, the remediation of all the vulnerabilities in proprietary code is not only an operose process, but at times it could be downright unfeasible. And the reason is that contrary to a vulnerability detection that over the past few years has largely become an automated process, automatic remediation is not so. So the purpose of this session is to unravel, if you will, some of the important aspects that underlie the concept of auto remediation, and in doing so, help clarify how organizations can not only promote and help their developers and boost their productivity, but rather help the developers realize a first-rate experience where they can alleviate the remediation burden, ameliorate the process, and accelerate the remediation completion. We have three main parts in our session here. I'll start with the challenges, some of the challenges that concern manual remediation, and it will be a good start to underscore the value of auto remediation. Then I'll move to highlight concept and a number of examples concerning the workflow of auto remediation. And finally, we will bring up a couple of challenges with regard to auto remediation. Some of the people I know, I believe that considering the question that is brought up front, they would probably say that now there's probably no reasonable way to expect this to happen. But obviously that will have nothing to do with remediation. They simply have no familiarity with the concept of developer happiness. But seriously, I think that when anyone wishes to discuss the idea underlying remediation and auto remediation in particular, one needs to fathom, when does vulnerability remediation begin? Many would intuitively and spontaneously say that, well, we have some fix already in hand, and then let's apply it. And that makes perfect sense, unless, of course, you consider that in many cases, dealing with remediation starts much earlier, when you have this strange and the unsettling sensation that something went awry and you need to deal with that. Well, I would argue that remediation should basically start from that point. And obviously, any guidance that we would have in our disposal could be extremely helpful. But regardless of the level of help that guidance would provide, it still places the onus on running the actual change, alteration, or update, remediation, in other words, with the hands of the developer, the AppSec personnel, or as the evidence shows us, commonly in both hands. And that, in a way, contributes to a level of noise that doesn't necessarily help facilitate the overall process. I think this sets a good stage to highlight yet another question at this point. Is remediation strictly a technical matter? We will discuss that as we move through the process of this presentation, but I would really appreciate if you could keep that in the back of your heads. It's definitely one of the themes underlying this session. So what are the key challenges that one could associate with remediation in general? I think that basically one could highlight them as being three main issues: scale, knowledge, and clarity, or perhaps lack thereof. With regard to the first item here, I think that one of the items that pops to mind has to do with the fact that there is a discrepancy between the bandwidth associated with development compared to that of AppSec. Now, some people will probably consider having a ratio of 10:1 to be pretty optimistic, and they would be right. But in most cases, this is really an optimistic case, because the ratio observed is more likely to be something in the neighborhood of 50 to 1, 100 to 1. And I must say that even 1,000 to 1, extreme as it may sound, is not, unfortunately, an outlier. Moving on to the question of security acumen, I think that it gets accentuated here because given the inexorable march of technology, security is a moving target. And it is not a given to possess the knowledge associated with security that would be of demand whenever we need to deal with remediation. So relegating such a responsibility to people who might not possess this type of knowledge is not only a daunting experience for them, but could prove to be extremely ineffective, let alone inefficient. And finally, when we look at the last item on this list, noise, well, noise is probably a byproduct of having yet another facet that incurs a certain level of overhead, and that is whenever we have false positive results, they definitely do not contribute to the process of remediation, because even though we might end up with a proper remediation, so to say, to such a case, what did we manage actually to solve? It's a false positive, and it adds more noise rather than reducing that. I think that to complement this picture, it would be of extreme value to look at some of the operational challenges that developers are most likely facing. And even though probably some of you may not necessarily associate each and every one of the items in this list as something that they're more familiar with, I would contend that for the most part, there is a lot of similarity. And I'm not going to discuss each and every one of those items. I'm probably going to just run through that, hoping that you will find some way to get yourself immersed in the process here, because unfortunately, this is something that many developers, if not all, need to spend time over at some point, from reviewing an issue when it pops up and hopefully being able to prioritize that in a sensible manner, trying to validate the issue that they have just to make sure that it is not necessarily a false positive. Then, and this is a critical part, researching the correct fix approach. This is anything but a given. It's not straightforward, and it requires an immense amount of focus, dedication, and as I already mentioned, knowledge. Now, this, by all means, is not the most difficult part, because in my opinion, once you happen to have something that looks good enough, then you need to establish what would be the preferred way to fix the issue at hand. And finally, if this were to be the only issue, then comes the next one, which is confirming that the fix just being applied is actually the correct one. If there is any stamina left at this moment, one would be expected to record the fix details so that not just for posterity, but even for the particular case of that user, in order for a next issue coming up and happening to, and just having a similar enough profile would not require us to go through all of this process, this rigmarole again. What is the effort for a single fix? Now, I know that some of you just inspecting this figure would go back and say, come on, this is not a realistic figure. But as it so happens, studies may show that this is actually a very viable indication of the time it would take should you actually encapsulate the time each of these processes that are outlined here are provided, and then concatenate them into a single chunk. That is a very optimistic thing, because as most of you obviously know, there is a very large difference between the time it would take to deal directly with an issue at hand and the time it would most likely take for the issue to go through the process from where it was discovered and up until it is fully solved. In such a case, we're not talking about half a day, we're not talking about half a week, we're not even talking about half a month. And to be honest, and unfortunately, in some cases, we are not even talking about half a year. This is probably one of the more deplorable aspects of dealing with remediation without using some kind of a process, but rather betting on best practices, so to say, that might enable us to deal with them in what is hoped to be a most optimistic approach. I think that part of the key problem here is that even though it is presented as a list, there is a lot of creativity associated with this thing. And this is really the perfect place to move to the next item here, which is, well, what automatic remediation is all about. In my opinion, it's really about transforming what I consider to be the art of remediation into a best practice. Yes, indeed, dealing currently with remediation has many facets that are redolent of art. We need to be, we are subjecting the process to a sincere level of interpretation. It is not consistent. It is also unpredictable. And it definitely does not give you any guarantee of the end results. Now, some of these facets might not seem that alarming, but when we are looking at the organizational scope of the issue, we would definitely prefer there to be a process that would provide us with some level of guarantee here. So what is the promise of auto remediation? Aside from outlining what you see here as the three main items, I think that first and foremost, it's about better software security. And it's not really just about providing a point solution to a given problem. If you look at the first item here that is captured, standardized fixed approach, it's about providing some way to facilitate the process of remediation, not just to provide an end solution or something that could be simply pasted on top of the problem that we have. Why is it? Because it is ultimately believed that we are not just carrying out a mundane effort of remediating issues, but we would like to get more and more into a state of mind where remediation is really something that accompanies the developer. It's not a one-off. It's not just something that you do occasionally. It happens to command a significant part of the developers or whoever is involved in such an effort of their time. And standardized fixed approach concerns triaging, prioritization, things that auto remediation is definitely associated with. Obviously, the ability to reduce the number of unattended issues comes to no surprise. And of course, prior to release. Agility and productivity are mainly about combating the security knowledge gap that was mentioned earlier, but also better allocation of the bandwidth that is associated with resources. Now, this is not necessarily the resources that you may have thought about. I'm not necessarily pointing at the developer team here. I'm actually talking about AppSec. AppSec is much more restricted in terms of its bandwidth, and being able to focus, to funnel their effort on things that matter in terms of their complexity. There are many security-related facets that do not necessitate processes that often take their time. And being able to concentrate their effort on those very issues would be of extreme value to an organization. And finally, it goes without saying that better team efficiency is a byproduct of what we have here in order to reduce the overhead. But I would be amiss if not to mention the matter of trust here. Trust is an important thing because developers, even though the promise of auto remediation is alluring, it is enticing, developers, let's be frank, might not necessarily accept that easily, let alone countenance it, let alone endorse it. And the reason is because there is a trust barrier. There would be some concern about whether or not a process that autonomously pushes changes into our code would not, perhaps inadvertently, wreak havoc in our cherished code base. That is something that developers are less likely to cope with. And auto remediation must be designed to accommodate that requirement. Can that be done? Most likely. How? Here are some of the ideas that could probably give you food of thought how auto remediation could consider making a contribution on the trustworthiness front. It starts from being there, simply being there. It should not be just on demand as a reactive approach that many might consider to be sensible. It needs to pop up and to be proactive whenever it senses that there is something that is worthy of providing some insight. I actually went ahead of myself because insight is part of the items that you will see in a moment. Accuracy is not just about providing the right fix. That would be really, it goes without saying. We're talking about noise here. not adding noise, but actually being able to reduce noise. Unambiguity is a critical part here because providing more than just one option for a fix is not necessarily bad, as long as they do not compete with each other, and as long as they make perfect sense as far as what they aim to achieve is understood by the developer. I mentioned insightfulness earlier, and the idea here is that when you look at a human advisor, you would probably make a point that trustworthiness of a human advisor lies to a great deal in an ability to give you something to think about that you may not have necessarily thought about earlier. That particular je ne sais quoi, that is one of the, I would say, the lodestones of trustworthiness. That's interesting. I would like to use that. I would like to actually approach that person next time because their way of thinking is very palatable. It actually connects very well with what I'm trying to achieve. Having that ability as part of auto remediation is not science fiction. It's actually something that goes hand in hand with the experience that a solution can come up with. Because when you observe what took place from the earliest point in time when the solution was brought into play, having that perspective could provide you with the ability to provide suggestions that garner more trust from the end user. But all of this would really be worthless if not for the ability to drive results. And that's why it's captured as it is. Let's see a couple of examples here. The first example is a concerns injection. And you can see here how a particular piece of data, the username, has been entered and is expected to be used as part of a SQL query to the database. Another example, which is similar in spirit, although here we have something more closer to a path traversal, a vulnerability, is the case where still we have something that is obtained from outside of the application. But here, in this case, the file name is to be sent to a certain target. Now, despite the similarities, what actually I would like to point at is the fact that in both of those cases, we have something that entered the system and is being used. The big question here is whether or not the developer placed the proper neutralization of the potential damage or vulnerability, what is otherwise commonly known as sanitization, as part of the process here. In this particular example, which is really pseudocode, you can see that it is not so. And from the source to the sink, a critical part that is missing is the sanitizer. The sanitizer would be expected to be something pretty straightforward, right? At least with those who are less familiar with the overall concept of a remediation. However, when we need to deal with automatic remediation, this issue becomes much more significant because here there are much more questions that need be not just asked, but answered as well. How should sanitization look like? Importantly, where should it be placed? How should new arguments be inserted? How should sanitization be annotated? And can sanitization inadvertently change the logic of the application? Most developers don't really, or perhaps even can't, give a second thought about preserving such a knowledge. And that actually comes into play when you look at the approaches that are currently used, leveraged to provide remediation. Facilitated remediation in a traditional manner goes from explaining the security issue to highlighting the issue, a location. Then comes the key part, guidance, how you should really address that. And in many cases, I would say that it is an apotheosis of, when you want to provide something that explains the issue, but ends up confounding the person and providing something that is not necessarily helping, which is actually something pretty similar to what I inadvertently did right now. Finally, we have the example. The example is something that is expected to provide the highlight here. Here is the aha moment. Here is how one needs to deal with the issue. However, I call this the training approach because the training approach bombards the end user with a lot of information, a virtual flashlight, a virtual magnifying glass, presentations, research material, everything which is unfortunately and honestly irrelevant to what most of the developers would be looking at that point. Their aim is not to become an expert. Their aim is to solve the matter at hand. And the way things need to be adopted, and this is how automatic remediation sets out to do, is embracing a developer standpoint, a developer perspective, where you actually aim to have some kind of understanding what the issue was, what the impact is projected to be, and importantly, and it's not just placed here on the top of the head, it's actually confirmation that we have something that will work. The high-level view of the process here would look very familiar to most of you. It starts with the coding, moving to the build process, then having the system automatically run a scan, which will then divagate to something that combines triaging with the generation of tickets, the remediation process, and finally ending up with the details that we see on our screens. The detailed view of that would have a detection facility next to the remediation, and more particularly the auto-remediation part. The purpose of the detection is to be the source truth for CWE detection, which is another way of saying that the details concerning the variables, the sources, the sinks, and the metadata associated with them needs to be provided to auto-remediation. Auto-remediation is a consumer of such information. And as you can see here, the way things could be extracted from detection here could be through a variety of formats, Serif being just one mere example for doing so, with the details concerning profile, code location, code trace, among other things. The main purpose of auto-remediation would be to come up with the analysis and recommendations, not just for the solution, but for the annotations, for the placement, and for what kind of actions need to be placed in order to streamline the process into fruition. And finally, the information will be passed on to whatever choice the end user made, whether it is IDE integration or through the CI/CD integration where you have a pull request. And there is an optional item here, which is to actually carry out validation for the recommended auto-remediation fix, so that you could be sure that everything was closed very neatly. Let's now move to a slightly more detailed example than the one we've seen earlier. In this case, this is no longer pseudocode. Now we're seeing a Java code where it is very similar in spirit to what we've seen earlier, but with a bit more detail to it. And here again, we see the external part that needs to be neutralized. In this case, it's called uname. And we have the connection object that happens to be the focus of the query method on top of that. Now, as you can tell here, there is no proper sanitization of anything. The main objective of an auto-remediation would carry out changes that will end up being modifying the code so that some of the items would be removed, other items would be added. Now, those of you who may not give a second look at the details here might say, this looks to be pretty straightforward, right? Well, even though this is a pretty simplistic case, I would like to point you at some of the nuances here that are anything but trivial. For instance, first of all, thinking about the approach, even though in this particular case, we see the use of a prepared statement, which is a way of using something that could sanitize by virtue of a pre-compiled statement that then could not be exploited by the external input, because it would only be limited to the parameter that is in question. And this is, by the way, a means that could be used not necessarily for sanitization, but for performance reasons as well. But there could be other approaches here. One could consider sanitization of the external input. One could even focus their efforts on authorization mechanisms that could reduce significantly the likelihood for vulnerability exploits in this case. But let's go back to the example that we have here and look very closely into the details. You will see that not only were just mere sentences removed and replaced by other things, there was a very careful attention here to make use of similar variables. And those variables need to be placed in some cases within parentheses of methods that were not trivially made available earlier. So the decision that needs to come into play here, and again, keep in mind, this is an automated process. So being able to make sure that this is done, and here comes the real crux, in a manner that will not look as if a machine did it. it must look as if the developer, actually a developer, suggested those changes. So I think that by looking into such an example and understanding, by the way, it might appear as a casual thing, but even the placement of the new lines of code here is not just a serendipitous. It just happens to reflect the particular way of thought that the application was expected. And that is part of the reason that you can see line 112 here, which really serves no purpose other than just saying that the application should be able to look into the workflow and make a conscious decision where exactly needs to place the actual new code. Of course, there are cases where auto remediation would fit better than others. And among the usual suspects, we would find cases where standard sanitizers are being used. Obviously, that would definitely lift up the chances for having a better remediation, because it would obviously and arguably, at least in my opinion, lift the chances for accuracy. The more accurate the solutions are from the detection system, the less likely remediation could falter. But there are other aspects as well. If it is possible to constrain or to at least focus the remediation effort on the area that could be detected prior to build, not that the value of auto remediation for dynamically detected issues is gainsaid. It is not so at all. But being able to run processes on things that could be statically analyzed gives a very sensible and decent percentage for success here. And aside from that, there are some other things such as remediation location. If, for instance, there is a preference by the organization to have a sanitizer that is located external to the component in question, and the reason being that they opt for an approach where they have a central sanitization mechanism instead of sanitizing wherever there could be a vulnerability. That's a viable approach. But in order to have that addressed by auto remediation must be smart enough, if you will, to consider that or to fathom that as part of its process. And finally, definitely not least, we have here the consideration of running auto remediation as close as possible to the detection phase. Obviously, as time goes by, changes will lurk within the code, and no longer the results from the detection step may apply. So there are actually also more client consideration. Just very quickly, I would say that the timing of auto remediation is pretty critical. You can opt for having it done as close as possible as part of the environment the user is actually leveraging, the IDE. But of course, you would probably lack context. And the later you could provide it, even though you're still shifting left, would be of enormous value here. Another thing is implementation. Would you prefer an IDE or a pull request? These are preferences. I mentioned earlier that one of the key ideas, in my opinion, for auto remediation kind of transforms us from art into a best practice. This is by no means a statement that says there should be no sense of art, or if you will, interpretation or creativity within the process. And I kind of use this reference, calling it a concerto in A major for keyboard and orchestration. It would be more apt in this case. And similar in spirit to a concerto, we have three parts here, starting with the quick one, where we run the automation. Then we move to some phase which is a bit more imperturbable. It is with the advise, you consider that. And finally, to the alternatives. Automation, or movement one, if you will, is really about avoiding noise. The advise phase or movement is about not dismissing the value of remediation guidance and ability to annotate changes. This is definitely a part of what we would like to provide here. And alternatives, well, this goes to the preferences, being allowed for remediation, application, style, and preferences of display, as well as the IDE and pull request. To summarize, remediation of security issues is indeed one of the most challenging aspects of development, but it is so because it demands security acumen and substantial resources that are anything but given. Auto remediation can enable a significant amount of productive impetus, but it will also increase, hopefully, and likely, the team productivity. And finally, auto remediation can realize, and that was probably the most important thing, better software security. And it will do so by reducing the unattended issue count significantly. Thank you.